You're probably wondering why I'm here. I'm doing some undercover surveillance on these dog walkers. I had this idea that people who aren't very hairy themselves would choose a very hairy dog to compensate for this. I've been jotting down some numbers, but I'm getting in a real muddle. What if I lose count? Will anyone take my results seriously? Here comes the rain. What did I do wrong? I'll answer that in one word: prepare. There's a huge difference between everyday wondering about things and the practice of scientific psychology. The main difference is that psychologists conduct systematic research in the hope of collecting data which can be tested. Doing an experiment is a bit like cooking a meal for your friends. You've got to plan ahead and follow a recipe. Most of the work is preparation. In science we call that research and design. Usually the idea is based on another researcher's findings rather than a mad idea like my hairy dog one. Psychologists can study an idea they've heard on the radio or read in a magazine. It's not usually based on such a pet theory. Anyway, let's for the moment consider taking another one of my ideas. My mum made spaghetti bolognese last week for me and a few friends, and everyone thought it was great. So my idea was to make a better one than hers. In experimental jargon, I'm going to replicate her work, and that is follow the same recipe she did and then hope to get the same results. I've never done this before, but Mum says it's pretty hard to go wrong. So here I go. But I'm going to make one change and put in some shiitake mushrooms. Now, they're not Italian, but I hope they'll make the taste much richer. In experiments, it's usual to change one thing. This is called the independent variable. We are adding some shiitake mushrooms. The IV, as it's called, is changed in some way to show an effect on the dependent variable, or DV. The DV in our experiment will be the difference in taste. Sorry about all the jargon, but it comes with every new skill, doesn't it? Even cooking. What on earth does broil mean? In experimental method, we would write down our idea and predict how it will turn out. We call these statements hypotheses. At the moment, I'm not very sure this is going to work. The mushrooms may not make any difference at all. I'll make this my null hypothesis. Note the singular. It is this statement that we're going to try and prove wrong. I think adding the mushrooms may not make any difference to taste at all, and I'm going to try and prove that I'm wrong, that it will make a difference. So, my hypothesis will state that there will be no difference between my spaghetti bolognese and my mum's spaghetti bolognese. Now, I think my friends may say that my spaghetti bolognese tastes different to my mum's, but it could be better or worse. We have to make a statement about this too, called the alternative hypothesis, because it's the alternative to the null hypothesis. It is saying that the change will actually make a difference. There will be a difference between my spaghetti bolognese and my mum's spaghetti bolognese. Note that it is sometimes called the experimental one too. This is a non-directional hypothesis because I haven't stated that my friends will prefer mine, just that there will be a difference. This is also called a two-tailed hypothesis because the result could go either way, improved or worse. Now, I know I wrote these hypotheses, but they're not very good ones. Why? Because I haven't given enough detail for anyone else to be able to replicate my experiment. I haven't said what was different about my spaghetti bolognese, and I haven't said how we're going to find out what my friends think. So, let's improve the null hypothesis a bit, the one which says there will be no difference between the two versions of the spag bol. There will be no difference between the spaghetti bolognese with shiitake mushrooms and the spaghetti bolognese without them. But that still doesn't say what method is to be used. Perhaps you could have a go at improving the alternative hypothesis now. What we need to do is to operationalise the hypothesis. It needs to say what method we will use to find out if my friends think there is any difference. Okay, you've probably had lots of ideas about this yourself, and it's probably started you thinking about the design of the experiment and the methods we could use to find out what our guests think. Probably the easiest way is just to simply ask them which one they thought was best. But best is not exact enough, as it could mean looks best, best texture, or the best one I've had since the last one I had. We could ask them which one they thought was the tastiest. However, there's always the possibility that the one they judged the tastiest they may not actually like because the flavour is too strong. Another way would be for them to rate each disc on a rating scale, say excellent down to a disgusting. We could allocate numbers to each value and then we could work out whether there actually is a difference. One problem with these methods is that the participants, as we call those taking part, will know that what we are testing. It's always best to disguise the purpose of the experiment so to avoid demand characteristics, and that is when the participants taking part give the answers that they think that I want, which is that my spag bol is the best. I've chosen an easy method for our purpose, scoring both meals out of 10. Easy, but open to error and bias. To prevent them all on judging on one particular aspect of the dish, such as appearance, we could add the word overall. So our final hypothesis may look something like this. Higher scores out of 10 will be given for the spaghetti bolognese with shiitake mushrooms than the spaghetti bolognese without them. And the null hypothesis, there will be no difference between the scores out of 10 given for the spaghetti bolognese with shiitake mushrooms and the spaghetti bolognese without them. Okay, so the next thing we have to do is decide who to invite, or as we say, select a sample. In an experiment, we ideally choose a random sample from the whole population we are interested in, which will be representative of that population, and we call this the target population. We must select from this whole population in a way that gives every member of that population an equal chance of being chosen to participate. This will produce a representative sample. You can use random number tables or computer-generated random numbers, or even a reliable bingo calling machine. The result would be a random sample which would then be representative of the whole target population. People often pull names out of a hat. Although this doesn't look very scientific, it's quite alright. Just make sure the items are well mixed and can't get trapped in any of the corners. But if we wanted a random sample of students, every name of every student would have to be put into the hat. This is obviously impossible, so we could choose all students in the college on a certain course, and if those students are all available to be chosen, then that would be our target population. We can then pick names out of a hat, and this sample would be representative of those students. If you have a huge target population, random sampling can be expensive and time-consuming. It would be easier if the sample was smaller, such as all one-armed trumpet players, but you still have to find them all. In reality, most experiments use opportunity sampling, that is, those who are available at the time. It may surprise you to know that the majority of psychological studies quoted in textbooks use opportunity sampling, usually using the researcher's own students. In my case, the target population would be all the friends I could possibly invite round for a meal. In practice, I've got to pick the same 5 friends who had my mum's spaghetti bolognese last week. This is called a repeated measures design. Everyone takes part in both conditions. It wouldn't have been possible to have separate groups called independent measures because they needed to make a comparison between 2 meals. Right, here are the participants. Alright, mate?
Alright, man.
Hello. Here's my room. Alright, just sit down and I'll speak in a minute. Right. I'm sure you can see weaknesses in my design and sample so far, but I'll let you pick it to pieces while I just get on with this. Well, the sample has not been randomly chosen from the target population, the whole group of friends that could have been asked. It was just an opportunity sample, or those who were available. One major problem with the design is that there was a week between the two conditions. This could cause primacy or recency effects. Primacy because they can remember my mum's better because they had that first, or recency because they've been asked to score mine just after they ate it. With repeated measures where everyone does two tasks, we have to counterbalance. That is, randomly select half the participants to do one condition first, and then get the other half of the participants to do that condition second. This prevents order effects, things like fatigue effects where participants become bored with their task if they have to perform twice under two different conditions. This could apply to eating spaghetti, of course, but we can't do anything about the order effects now, as they've already eaten the first condition, my mum's spaghetti. Another order effect in some experiments is a practice one, where everyone may do better the second time, and this can produce confounding variables. A confounding variable is anything other than the independent variable that affects the results. Watch out for confounding variables, and I'll see if you've spotted any afterwards. I'd better be sociable now. I have to go eat with them, or they may suspect this is an experiment, rather than filming for a social psychology video like we told them. Yeah, I'm afraid we have to use a minor bit of deception in most experiments.
Oh,
Sniffers.
a lot of the problem with sniffers.
What's a
Sniffers.
sniffer?
Oh dear.
Nice.
Yeah.
Right, I've left them all to clear the table while I come talk to you. I thought spaghetti bolognese was really brilliant, but we'll see. Another consideration I forgot to mention was where we have the experiment. Obviously in the kitchen, unless we decide to do a field experiment. But in fact, a field experiment is nothing to do with fields, unless you're studying the natural behaviour of grass. Is when you perform an experiment in its natural environment. And as the natural environment for eating spaghetti is in the kitchen, back we go. The opposite of a field experiment is a laboratory experiment, which can take place in a laboratory, but it really means any artificial environment which is not a natural one for the activity. If you're studying chemicals, a laboratory would be a very appropriate place, but certainly not to ask people to eat spaghetti in. The advantages of using a field experiment like ours is that it has more ecological validity. That is, it relates to the real world. People are more likely to behave naturally and the results can be generalised to other situations. However, it is more difficult to replicate and you do have far less control over variables.
I'm rather excited about that. Oh, sorry.
Oh, thanks.
Sorry.
Well done.
It sounds as though they've settled down next door, so let's straight in with the scoring. I've planned what I'm going to say, and although they're my friends, I still have to give what we call standardised instructions. These instructions then go into a report, so another experimenter can copy what we did exactly, using exactly the same method. You'll notice as you're looking over their shoulders that I'll be counterbalancing the order which they give me their marks. 3 will mark Mum's first, and 2 will mark mine. Right then, here we go. Okay. Alright, can you just give me a hand with something for a minute, everyone?
Yeah, sure.
Right, I'm giving you a sheet which asks you to score spaghetti bolognese out of 10. 1's the lowest score, and 10 is the highest. Please don't speak to each other or look at anyone else's paper. Do it as quickly as possible, fold it in half and hand it back. You just take your pencil and do that now. Thank you. Thanks. Thank you. I'm now giving you a second sheet. Read the sentence at the top, fold your paper, then hand in just like you did before. Alright, thanks. Ah, thanks for that, everyone. I'll just tell you what, I was about over a cup of coffee or something later. Well, here are the results. I counterbalanced the presentation of the score sheets. The scores in red are those who marked Mum's spaghetti score sheet first. We now have some quantitative data, that is numbers, and we could do a lot more with them, but we'll save that for part 2 of this series. Just looking at the scores and the sum of the scores, we can do what is called the eyeball test. It looks as if the shiitake mushrooms did make a difference. I can now reject the null hypothesis, which said there would be no difference, and accept the alternative hypothesis that said there would be one. We can be fairly sure that this wasn't due to chance or error, that is, that the independent variable really did make a difference to the result. To be even more certain, we need to do a bit more number crunching, but we can worry about that in the next programme. Remember the two-tailed alternative hypothesis? We thought it could go either way? Well, if we had done a very tightly controlled study and felt very confident about the improvement the mushrooms would make based on past success with this recipe, we could have used a one-tailed hypothesis. This would say that the spaghetti bolognese with shiitake mushrooms would be scored more highly out of 10 than spaghetti bolognese without them. So, a one-tailed alternative hypothesis states the direction we expect the results to go. Now, what about all the error and bias that creeps into even the best experiments? Remember we said that a confounding variable is anything other than the independent variable that can affect the result of the experiment. So, what do you think could have produced the difference in scores apart from the addition of shiitake mushrooms? I bet you have a huge list of possibilities, so let's try and separate them out into constant errors, random errors, experimental bias, and demand characteristics. Constant errors are those things which affect the group in a constant way and can be very serious. In our experiment, it could be that the friends that were available to come round had all been out for a spaghetti bolognese during the week, and this could blur their memory of my mum's spag bol. Or maybe I hadn't been careful enough with the recipe and put double the quantities of salt given in the recipe. Random errors usually only affect one participant. For example, one may not be feeling well and not feeling like eating, or maybe one person doesn't like mushrooms. If you have a large enough sample which has been randomised, then these random errors will hopefully even themselves up and are not thought to be too serious.
Guy, Francis Black, but he is a bit of a god still.
Experimental bias is when the experimenter unwittingly reveals the purpose of the experiment and gives away the outcome that's expected. This can be using non-verbal cues or saying something. Although I was desperate to know if they liked the meal and noticed the mushrooms, I was careful not to make any comment about the food. Someone said it was very good, so I just said thanks and distracted them with that joke about a frog who won the lottery and blew it all on a makeover. Didn't go down too well anyway. Any conversation with all participants would produce constant error. If I had told them about the mushrooms, then they would be aware that I had changed the recipe and that I was expecting it to be an improvement. This in turn would lead to demand characteristics. This is where the participants try and guess what the experiment is about and then behave in the way they think is expected of them. But because they thought this was filming for a social psychology film, they would have been more aware of how they were acting, but it would not have influenced their scoring of the spaghetti. There are solutions which fix many of these problems. Randomization of participants and conditions, counterbalancing the order which they do the test, and using double-blind procedures where neither the participants or the person administering the experiment know what is being tested. Remember that I started sitting in the bushes watching people walking dogs, with no real hypothesis to test, no experimental design, in fact no planning at all, not even an umbrella. We've come a long way since then in understanding the importance of a systematic approach to testing our theories, and the importance of controlling sources of error and bias. Now, there is one very important thing that must always be done as soon as the experiment is over. Debrief the participants. Yes, they're still here. To avoid all the error and bias we've been talking about, we sometimes have to use a bit of minor deception. But at the end of the experiment, we've got to tell them what the study was about and allow them to ask any questions. But the question of how ethical the study was will have to wait to another programme. My coffee's getting cold.
You are joking.
That's more than probably me and Miriam.
It's combined, yeah.
That is.
Are we girls?
I'll drink to that.
Maybe we'll have many happy returns.
So what was that all about then?
Well, it wasn't exactly social psychology. Remember last week you all came around and had spaghetti bolognese with my mum? Well, I thought I could do a comparison between her spaghetti bolognese and my spaghetti bolognese and see what difference adding shiitake mushrooms would do.